Hi, I'm Kesi Survikesan. So I'm going to present the question number one of our mini project. So the question is write a simple C++ program that inserted a list of data into stack S. As shown in following is figure. At the end of the program, show the pop operation to remove all elements from the stack. So this is the question, which is you can see there's a PUO into the stack, which is the elements. So now I will show you the is in the next part I will show you the answer and explain about it. So as you can see, this is our C++ program coding for our question. Okay, now I will give you the explanation of the C++ code line by line. So as a tradition of the code, the header files, which is include iostream. The include iostream allow you to use cout and cin, which is input and output. And then include stack gives you access to the stack data structure provided by C++ standard template library. And then the using namespace std, this line saves you from writing std again and again. It's like a shortcut. And then int main is this is the main function, the entry point of every C++ program. It's where everything starts running. So and then going into the coding, stack char s, this line is declaring a stack named s that will store characters, which is the char. And then this stack works on the last in and first out principle, which is LIFO principle. The last item pushed will be the first one popped. So and then moving to the next part, s dot push p, s dot push u, s dot push o. These are the pushing elements into the stack. These lines insert values into the stack. The push bracket function adds an elements to the top of the stack. After pushing, P goes in first bottom, and then U, and then O on the top. So the stack looks like top in the top O U P. It's look like that. And then the next line is C out stack has been filled. This simply prints a message saying the stack is ready to go. The next line is the next line is for popping and displaying elements from the stack. See out now popping elements from the stack, which is pop element from the stack. This line begins a loop that runs while the stack is not empty, which is the while not s empty brackets. So the S empty bracket checks if there are no more elements. Not as empty brackets means keep going as long as there are elements inside the stack. So that's how the loop works. And then the next line is C out S top end. The S dot top bracket accesses the element at the top of the stack without removing it, and then C out prints the top element to the screen. And then the next line is S dot pop bracket, which remove top elements. This s dot pop bracket removes the top elements from the stack. It does not return the value. That's why we got it with s dot top at first, the first of the lines. And then return 0. Once all elements are popped and printed, the loop will end. So return 0 signals the program runs successfully. So this program and this coding is created for a stack which inserts three characters PUO. It it then removes them one by one from the top while showing each on the screen. Because it's LIFO structure, the output will be OUP. That's all. Thank you. And one more thing, this is how the output will looks like. Thank you.
A very good day to Puan Anisa. My name is Devin Priyasri Anna Prabhamurthy and metric number 01DDT22F1142. I'm going to present to my answer for question 2, which involves using a cube in C++ program. This task is to insert specific data into the queue and then show how we remove or dequeue all the elements at the end of the program. So these provide a queue with the three characters P, U, and O inserted in their order also. It also shows the position of index 0 is the front and the index 3 is the rear. This represents a FIFO data structure, first in and first out, which means first element added, which is P, it will remove the first to be removed. In this program, I include the iOS stream and the queue library to support input, output, and the queue container. I use a queue chart because we are working with characters. First, we insert P, U, and O using a push bracket function. Then I use a while loop, remove all elements from the queue. The function queue front bracket give us the front element and queue loop bracket remove it, and the loop continues until the queue is empty. This is the output. As you can see, the elements come out in the same order they were inserted. As they show, the queue works using the FIFO principle. That's all from me. Thank you.
Good evening, madam. My name is Elishala, number matrix 011DDT22F041. Today I'm going to talk about question 3, writing a C++ program to show the implementation of a binary search tree using database. The program must include all the operations in binary search tree, including creating BST, inserting item into BST, count item in BST, deleting item from the BST, and traverses of BST.
Okay, first one is we need to do include IOStream using namespace std. Second is define a node structure, which means like structure node, uh, in integer data, node left, node right. Second part is creating a new node, which means like node, create node in a bracket, integer value. And second is node, new node equals to new node. New node data value, new node left, new node right, null ptr, and return new node. Third one is a insert item into a BST node, insert node root integer value. If root equals to null ptr, return create node value, else if value root data. Root left, insert root left value. Else if value root data, root right, insert root right, value return root. Okay, next one is an in order traversal, left, root, right, which means void in order not root. If root equals to null ptr, in order root left, count root data, in order root right. Second is a pre-order traversal, root left right, which means void pre-order not root. If root equals to null, cout root data, pre-order root to left, pre-order root to right. Post order traversal, left right root, which means void post order not root. If root null ptr, post order root left, post order root right, count root data. And then is count not in BST, integer count not, no, not root. If root null ptr, return 0, return 1 plus not root left, count not root right. Third slide is find minimum value of not find minimum, meaning not root, where root and root left equals to null ptr, root left, return root. Deleting item from
BST means not deleted not root integer value. If root is equal to null PTR, return root. If value root data root left delete not root left equals to value, else if value root data root right deleted not root right value not founded. If not is founded, root temp root right delete not return temp. Else if root right null ptr not temp root left delete root return temp. Not with two children, not temp root data temp data root right delete not root right. For forward slash is main program, integer main not root null pti, integer choice value well true. First is binary search tree menu, second is insert item, display in order, display pre-order, display post order, fifth is count item, six is delete item, seven is exit, the last is enter your choice and then choice. If we use switch in here, switch choice, cases 1, code enter value to insert, scene value, root, insert root and value, break. Case 2, cout in order traversal, in order root, cout and break. Case 3, cout pre-order traversal, pre-order root, cout and break. Case 4, cout post order traversal, post order root, cout and break. Case 5, cout total item, count node root and break. Case 6, cout enter value to delete, scene value, root delete not, root value break. Case 7, cout exciting program, return 0, default count invalid choice, try again. Okay, this is our output. Will be display binary search tree and a 7 item, and then enter your choice and then enter your value insert, and then you can choose 1 until 7 which one you want, which means can insert item, display in order, display pre-order, display post order, count item, delete item, exit, and then last you can exit the enter your choice. You can enter number 7 which means like exit, and you will exiting your program. Thank you.
Good morning, madam. My name is Saranyana Prapan Aramukam. My check number is 01 DDD 22F2009. So, my part is question 4. Based on the figure below, illustrate the step to find the key of 50 by using binary search method. Okay, this is question. Okay, this is my answer. Okay, next slide. I show how to solve the question method step by step. Okay, now I show the method how to solve these questions. Okay, first of all, this is our question. So our target key is 50. Target key 50. Okay, first we just fill up the numbers. Okay, for index 0, 5, 11, 19, 25, 34, 42, 47, 50, 58. Okay, now okay, this is first, and then this is last. Okay, now we find the middle. 34 is middle, so now we 50 our target key more than 34, so we didn't get the target key. So now here just same, we just put the key, numbers 1, 19, 25, 34, 42, 47, 50, 58. So now the first is we put here first, and then middle is for 47, index 6, last is index 8, 58. Okay, now we find the target key. 50 more than 47. So here also we didn't get our target key. So here fill up numbers 19, 25, 34, 42, 47, 50, 58. So first is here index 6, and then middle is index 7, last is index 8. So here we get our target key equals to 50. So the answer, okay, target key is found at index 7. That's all. Thank you.